This is a buckling analysis for a rectangular cutout plate. The first step is to define the geometry. We start by creating a large rectangle with dimensions of 2 meter in height, 1 meter in width and the thickness of 0.01 meter. Next we create a smaller rectangle which will serve as the cutout with dimensions of 1 meter in height and 0.5 meter in width, the same thickness of 0.01 meter. We then separate the smaller rectangle from the larger one, which will give a rectangular cutout in the center. Once the geometry is ready, we move on to meshing. So for this we will first apply a surface mesh, selecting the polyhedron mesh option. Afterward we use the sweep option to convert the surface mesh into a volume mesh. We then assign the material properties, so we'll use steel as the material in this problem. Next step, we apply boundary conditions. So for the boundary conditions, we'll restrict one surface in all directions and we'll apply pressure in the opposite direction of 30,000 Pascal. Finally, we set the calculation method to buckling analysis and specify 3 buckling modes and type to linear. Once the analysis is run, we use the FIDESYS viewer to observe how the plate buckles in each of 3 modes. And to perform this analysis, these are the 5 steps we need to perform, and these are some analysis types and settings we will use further. And next step, we will delve into FIDESYS software to perform this analysis. Now to create the geometry, in the command panel, select manage geometry, manage volumes, then select create volumes. From the list of options, select brick, enter the rectangle dimensions, width of 1 and height of 2, then depth of 0.01. Click apply, and we need to create the second rectangle, so enter the dimensions, width of 0.5, height 1 and depth 0.01, and you can see 2 rectangles were created. Now we need to separate the second one from first, so move to Boolean operations and then select subtract, select the first volume and then second, then click apply. The next step will perform mesh, so select manage mesh, then select surface, then specify meshing schemes, then from this select polyhedron, then select this surface, then click on mesh. So this will generate a polyhedral mesh, or if you want to change to submap, you can select this and click on mesh. So I want to sweep this surface from this surface to this bottom surface, so go to volume mesh, then select the mesh type to sweep, so select this volume, then source volume will be the meshed surface and target surface will be this bottom surface, then click mesh, and we completed the meshing. So the next step is to assign the material, so select manage materials, so enter the name of the material steel. Now drag the material properties, hook material, enter 2.1 E plus 11 as the Young's modulus and Poisson's ratio to 0.3, then click apply. In order to assign the material to this rectangular plate, we need to create a block. So to create the block, click on manage blocks, then select manage extruded blocks, then click on this first option, add. Now from this list you can create a block for surface, edge or curve. So we will create block for this volume. So you can click from this interface, or you can right click and also select all and click apply. Once we created the block, we need to assign the material to this block. So the next step is to click on this second option, assign block material. So from this option, select block name and select the material, then click apply, and we added the material to this block. So the next step is to add boundary conditions. So click on boundary conditions, so click on displacement, then select create. So click on surface, so we will apply displacement to this surface. So click on this surface, click on all, so we'll fix in all directions, so it cannot move in any of the direction. You can set the degrees of value to 0, or it will automatically set. So click apply, you can see it is automatically fixed to 0. The next step is to apply pressure. So I'll apply pressure on this opposite surface, so click here to add this pressure. I'll apply a magnitude of 30,000 Pascal and then click apply. So pressure is applied on this rectangular plate, and the last step is to calculate. So click on this calculation settings and navigate to buckling analysis. Click on general settings, set the type to linear and set the number of buckling modes to 3, then click apply. Before starting the calculation, you need to save the file here. Now start the calculation and save the file. So this will take a few minutes to run the calculation, and the calculation is finished. Once the calculation is finished, we need to open the FIDESYS viewer to view the results. So open the FIDESYS viewer. Now once the FIDESYS viewer is opened, now we can start by looking at the results for the buckling modes. So here you can see different modes. So rotate this, so we use this warp by vector. So set the scale to highlight the deformation. So you can see that, so when the plate begins to buckle under pressure, the material around the cutout will typically bend inward or outward depending on the load direction. So this creates bending around the corners of this cutout where stress is higher. So if I change this scale factor, this deforms more. And we can check out here where the failure will occur. And this is the end.